Hey everyone. Hey everyone, and welcome to the sixth stream on Tetris programming, where we are going to code Tetris relatively from scratch, starting off using Raylib. And today what we're going to focus on is creating ghost tetraminos and maybe doing a hard drop. So where we were already is we have our tetraminos that can move around. You could use the various buttons to swap in and out different tetraminos as you need. So let's actually make sure that this S piece is the correct color, because right now it's white and we were doing that for some testing. So I'm going to come here, change it to green, build it, and then we are good. So let's go to my drawing program where we'll talk about how we might want to implement this. So first, let me paint some tetraminos there. Okay. And what we essentially want is, say that this is our playfield, right? And let's say that we have an S right here. So this is our S piece. And what we essentially want is a way that we can see where the S piece would go when it ends up falling, or if we were to perform a hard drop. So those would be right here. Let me just write ghost tetraminos, because that's what we're talking about. Right there and right there. So we essentially want to display maybe with a transparent green, or maybe rectangle lines instead of a filled rectangle. But for right now, essentially some way that we can show this is where the Tetris would go if it kept going. Along those lines as well is that if we have solid tiles here, like, so say there is some solid tiles here, or just blocks, is what we would want is, so now this would be the place that it would fall and where we want to render the ghost. So we need to develop some way that the playfield, or I guess the code, could see the active tetramino. And essentially what we would want to do is look at all these blocks, and we want to draw, I shouldn't say draw, but what we want to do is go down the rows until we get to an intersecting one, where the ground would essentially count as an intersection. We want to go through all these pieces, so that one goes there, and then that one would touch, and then this one would touch. So then what we want to do is we want to get this particular row that it would be at, and this particular row. So if this is starting at 0 and it's going all the way to 19, is that this would be row 18. So we would store that row 18 is the row that it would intersect. So by that token, 17 would be the lowest it can go. And then what we would do after that is essentially calculate the we would see that 17 is the lowest it could go. And then what we would want to do is bring down, I don't quite know the details, we'll just have to look into it. But essentially we want to bring down this piece as far down as it would go till it touches. I'm not getting into the details just because I think once we start getting the code going and we start experimenting, and now that we have hot reloading working, we can do a few things to test out what might work. So I think the first thing that I kind of want to do here, let's go to where our active tetramino is. So drawing the blocks, draw falling block, block to place. So this is drawing, so draw blocks in playfield. And then this is drawing our active tetramino. And then what I want to do somewhere, so draw the falling block, enter places it. Somebody rename this. So let me just name this so that when I look at it, I know what exactly is going on. And this is just kind of making sure that the tetramino stays inside the playfield. Which we end up will probably changing this so that this only runs when we move it. So, and then finally we want to draw them. So what I'm actually going to do really quick, I think, is take this and kind of put it into a function. And what this is going to do is this is going to take the active tetramino, which is being stored in, let's just call it tetramino space up here. And the active tetramino has a position, so the active tetramino position. And what happens is there needs to be a translation that takes the tetramino space and then moves it into playfield space. So we'll just make a function to do that because we're doing it in a few different places. Or let's just say tetramino to playfield space. And that takes in a let's just say it takes in the playfield position, be an int. It takes in the tetramino shape, and then it takes in, how would I want to do this right here? So let's just say for the drawing, is that for all of this, I think what I would want to really say, because we only have one active tetramino here. And I think because this gets all the blocks. So I guess for right now, we could essentially pass this in here, and then it converts everything. So this would essentially take in a tetramino shape, and it would output a tetramino shape. And then what it does, I think that would actually do it. So this would be like playfield tetramino shape. And then I think all we would have to do is take the T shape and plus the playfield position, then return playfield tetramino shape. Would that, no, it wouldn't. So let's just loop over it all and do that. Yeah, let's just set it to a blank one, so tetramino shape. Then what we would do is we would say for block in T shape. What we would want to do is the play field Tetramino shape I is equal to the block plus play field position. I think that would do it, yeah. Okay. So let's try that. And then we want this to take in PST active Tetramino position. And then there is a few places that we are drawing, is it? Well, there's a few places we're drawing blocks. I think it's okay for now. So then what we would want to do is for Tetramino in playfield space. And then we probably want to have block to screen space. So and that would just take in block pause. And for right now, play field pause. And then cell size. Oh wait, this would be an F32. Block pause would be 2 ints, and cell size would also be an F32. Then what we do is block rect, that could be RL rectangle, and then so plus block pause, and where were we? What were we doing? Plus that times cell size. Put that in parens just for me to see. And then I want this to be cell size -1, and that to be cell size -1, so that we could fit it in the grid there. Field position, block pause in playfield space and cell size. And then all we gotta do is There we go. Okay. So what we kind of want to do now is do the ghost. So the ghost. And how we want to do this is we do want to get the tetramino in playfield space. The active tetramino position. And then the active rotation. And what we kind of want to get is the highest, or the closest secting row. I think, yeah. So it'll be an int. And then for block playfield space in tetramino and playfield space, we want to get the block. So actually, no, we don't need to get a block rectangle. So what we want to do is see if it collides with anything in the playfield, which would include one of these blocks, and then which includes like one of these blocks, and also the ground, because that's really where it would collide is the ground and then one of these blocks. So yeah, I would say block 1 is that, and then until, because there's always going to be a ghost essentially. So there's always going to be a ghost because it will at least collide with the ground. But let's see. So what we actually do is the closest intersecting row would actually be a row that isn't actually there. So closest free row, which would be 19. And then what we'd want is that the y is greater than or equal to 19, and then y minus equal 1. I think. Actually, no, y plus equal 1, and y is less than 19. Because essentially the y is like growing downwards. So that this is 17, this is 17, 18, 19. So what we want to do is for x in playfield state at the y, and we want this to be y test. And then what we want to check is intersects would be PST playfield state at y test, let's just say block test y, block test x. then the closest free row would be, the closest free row would then be the y test minus 1, I think. And then active. And what we're going to do is just a test for now, is draw this whole row, I think. So, for x in PST playfield state, for the closest free row, is that doable? Let's just do this. So, okay, so for in closest row self states, we are just going to draw rectangle rec. So what are we doing up here? So the block, that would be the column in the row. Let's just do draw block, and that takes in the playfield position. It takes in block, pause, and it takes in the cell size. Then it would basically do this stuff. So we come up here. Playfield position would be F32. The block pause would be 2 int. Cell size would be F32. And then it doesn't return anything. And we just come down here and we do that, and we do this, and we do that. And we do this, and we do that. And then we do this, and then we do that. And then, so that would be the block pause X, Y, and then block, and then we want, yeah, we get that cell. Cell active, so we probably want to put, yeah, also the color, I guess. So color, RL color. And there we go. And then we go back down here. This one takes in cell.color. And and then I think if we do that, we build that, it's the issue. Do that, do that. Whoa. That's drawing fine, but that's not. So, oh. There we go. That looks more like what we want. And then, yeah, so let me get rid of this. And then in here, what we want to do is draw block. So PST playfield display field position. And then the block pause would be so this would be the so x closest free row. That would take in the block pause, and then the cell size, and then the color. So it'd be cell. Let's just make it yellow or white. Why not? So that. Okay, so that is what it is determining that the closest one would be. Oh, break. There we go. I mean, that looks good to me, because if we put one right here, so that's good, but that's not. That's good, but that's not. That's good, but that's not. And the question is why? Oh, okay. So what we want to do is we only want to set the closest free row if it's actually closer. So yep, let's go in the debugger, I guess. Because so this works if that blocks. So my assumption. Oh wait, that's correct. That's actually correct. Let me make this, okay. I mean, that looks good to me. Let me make it transparent yellow. Yeah, I mean, that actually looks good to me. Okay. So now, instead of this, well, we want to draw the ghost. We will use it also for displaying it, as well as doing like the hard dropping, but we'll do that in a sec. So if we get the closest free row, what we would have to do, well, I think it might just be moving at the difference between that and the closest free row. Let's see. And I know this isn't going to produce like an actual thing. So tetramino in ghost in playfield space. Tetramino, to playfield space. Position would be the ghost tetramino pause, and then it would be this one. That shape. And then what we would want to do is this. And we want to draw this as, I'll draw rectangle lines. Yeah. Block. Okay, so that's where it's drawing it. Which is incorrect, as you could see, because we want it. So let's actually draw where the position is. And then the cell size. And this returns F32. F32, which would essentially be playfield origin x plus position x times cell size. And this would be an F32. And then we pretty much do the same thing for the y. Playfield position is screen position, and that would be a PST play. Oops, that would just be a playfield position. Dang it. Position, and then we want the ghost tetramino pause, and then we want the cell size. And then let's draw, so draw circle V. The center will be the ghost tetramino pause screen space, and we'll make the radius like a 2, and the color we will make a purple. Let's make it a white. And let's make this a 4. Okay. So what would it have to be in order to get the actual ghost tetramino pause? So we have the closest free row, and we know that so it's the fact that this is the closest free row available, but there's one under it. So what's the missing piece of information that we would need to get? Well, let's go back here. So we have this guy, and then we have this guy. So if this is at, let's just say like 5, 5, right? And boom, boom. So 5, 6, 7, 8. And if this guy is at 6, 8, right? We know that this one is at 6, 6. And we want him to be at we know the distance. We could get the distance 1 from the bottom. And then what we could do is say we could get how tall it is, which is 2. So we know that the closest is 7, right? I mean, I feel like we should just keep moving it down until we collide. I feel like we should just keep moving it down until we intersect and then just stop moving it down. We're already finding that. So and we know the intersecting row, which is 8. And we know the touching y row, which is 6. So if the touching row is 6 and we want it at 6, then maybe it would be the so essentially we know the pause that it would be at, which is here. We'll just keep collecting more data. Closest. So Well, no, because so you could tell when a block collides with it, but you don't necessarily know, like, well, we already do know the distance, which is because it's literally in tetramino space. So I feel like is it the closest free row minus need the closest. Y equals whatever, 19. And what we say is to save the Y test. So if the closest blocks, then the block test. So if intersects is closer is closer, that makes the closest free row, and the closest intersecting block Y would be equal to the block in playfield space Y. Y straight up. And then I don't even remember what I was doing there. No. It's a tetramino in playfield space. But we want the block in playfield space. That might have been a mistake putting that in a function. I don't know. But it would be the block in playfield space minus the active tetramino position. Well, maybe not. Totally no. What I think I'm going to do instead is loop over the tetramino blocks. We'll see. I'm going to say Okay, we actually don't want to break. Who knows? Maybe that was the issue all along. Oh yeah, you do actually want to break if the block intersects. Or that. Not quite. 0, 1, which isn't going to intersect. But this one should. This 1, 1 should intersect, and it should be closer. Okay, so it intersects. And the y test minus 1. That skips over. Really, I think we should do that because we need to check not only is it closer, but also if that particular block is closer. So what I want actually, because now let me draw. If there's two. So I think what I'll end up needing to have is some type of like intersection that checks like is colliding with the playfield, and it will collide with the walls. I don't know, is block here. And basically what we're doing here is making it so it returns true if you are anywhere kind of outside the playfield, because that's considered, I guess, the wall. Mhm. Hmm. So we are at least getting it correct when there is one thing on the floor. Let's try rotating it. What seems to work when rotating? That works. Yeah, I think those are like the biggest ones I wanted to see if it works. But it seems that it still will cry if that happens. And I mean, that one should intersect. Right? Yeah. I think we actually want to do up to 20. Let's try that. Ah, there we go. All right, cool. So let's get rid of that. And we'll stop drawing the closest that. And I think what I'll do is make this a bit bigger. And then all we gotta do now, so yeah, let me just get rid of that because we don't need that visual anymore. And what even was here? this. So what we will do is if you hit the space, then we'll put that there. So what we'll do is in playfield space, this would be tetramino playfield space, and the playfield position would be the ghost tetramino pause, and then the T shape would be this one. All right, and then what we would do is for ghost block in ghost tetramino and playfield. So ghost block playfield. And then what we would do is place, so what was I doing when I was pressing enter? That stuff. So I'm going to put that in a function, I guess. And what we want to take in here is so it won't be the active tetramino, it will be the T shape. Just do that T shape. Yeah, I think the active color is fine. So let's see if we could do that. So spawn tetramino, and then in here we want to pass in this guy. Cannot call non-proc of type bool. Set active tetramino. That. So let's comment that out and make sure our enter button still places it. Yep. Okay, so then what we want to do is do that again, except for the ghost tetramino on the hard drop. So actually, we want to take in the pause. Yeah. So the active tetramino position, we want to take in that pause. And then in here, when we actually place it, we do want to pass in the PST active tetramino position. And then down here, we want to take in the ghost tetraminopause and get rid of that. And then so now if we press the space, let's do this. So if we press the space button, there we go. So that would essentially be hard to drop in. So now you'll see, like, when we press the space, it sends that down to wherever it needed to be. So boom, 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 boom. Now we can let it fall slowly. Boom. So cool. Now we got some semblance of hard dropping going. So if we're in here, whoa. It's like phasing through. L, boom, boom. 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 That's cool. All right, so we started getting some functions going. And I think next time we'll look at it to see if those is actually the functions we want. Because I think I started creating them thinking that's what we would want, but then it ended up not being. One situation was because in this case, we actually wanted to know like the tetraamino space block, because that told us how much to move it back by there. But all right. Well, that's all we got for today. Thank you.